structure of how the galaxy looks like. So as I told you, our galaxy has a disc-like structure. So this is basically the disc, and the dark patches which you see is basically dust. Okay, there is no stars in it, and this is the center of the galaxy, or otherwise it is the galactic center. Okay, and above the galactic center we have what is called the galactic bulge. Okay, and far away from the galactic bulge, this whole structure is what is called the galactic halo. This is the halo of our galaxy. Now when you see about the distribution of stars in this structure, you can clearly see many different colors, right? So we will see what these colors basically indicate. So as of now, what you can say, in the disk of the structure, disk of the galaxy, you see mostly blue-like objects, right? Whereas far away in the galaxy, you see basically some reddish kind of objects. So what it tells, in the disk of the galaxy, we have newly formed stars. They are basically young stars, okay? So these young stars are basically called population 1 type objects. They are population 1 type objects. They are in the disk of the galaxy. And above the disk of the galaxy, we have some reddish structures, right? They are called population 2 type stars. Okay. So when you talk of population 1 type stars, they are stars which are younger in age. So they have ages, they are young stars. Young stars are basically metal rich. And when you see the metal content of the stars which are in the halo of the galaxy, they are old stars. If they are old stars, they carry the chemical composition when they are born, so they are basically metal poor. Okay. This is how the combination of the how the properties of the stars as and when they are in the disk of the galaxy. Okay, not only disk. Okay, so now you may know what is the reason for getting metal rich, right? Because when stars are born, they form in a wide range of masses, low mass stars to high mass stars. Okay, so depending on the mass, the evolution of the star happens. So the high mass stars, what it does, it evolves so fast. So as it evolves fast, depending on the mass, it may end its life as supernova or anything. So during the stage of the evolution, the star may, because when the star is evolving, what does it mean is hydrogen is continuously burned to helium. So when hydrogen is completely exhausted, helium starts burning. So when helium starts burning, it gets converted to carbon. So like this, materials are continuously cooked in the stars. So when the star dies, all the material is thrown away. Okay. So the interstellar medium gets enriched in metals. And when new stars are formed in this enriched medium, they are always metal rich compared to the older stars. So because of this reason, stars in the disk are metal rich compared to the hollow stars. Okay, so these are the properties. And now all these objects in the galaxy, they are always in continuous motion. It's not stable system, right? So all these objects move around the galactic center. So if you take the sun, for example, it takes roughly 250 million years to go around the galactic center once. Okay, now let us go further into the constituents of the galaxy. As we told, the galaxy has gas as well as dust. Okay. When we think of the gas can be in many forms. Okay, so if you take a cold gas means the temperature is of the order of tens of Kelvin. So when the gas is cold, the gas mostly exists in the molecular form. Okay. Many atoms get combined together to form molecules. So at this cold temperature, many of these gas constituents are in molecular form. So, however, when the temperature slightly gets increased at higher temperatures, these molecules disintegrate and form atoms. So at higher temperatures, the gas will mostly be in atomic forms also. And these atomic forms can also be traced through observations, mostly through radio observations, the typical wavelength is 21 centimeter. So this you might have read in quantum mechanics how this 21 centimeter line comes. Okay, and then we also have higher temperature regions in the galaxy. The temperature is of the order of 10 power 4 Kelvin. So most of the atom gets ionized. Okay, so at this temperature, what you see is basically ionized gas, and this is the condition which prevails in star forming regions. Okay, then again, there are still higher temperature regions in the galaxy, having temperatures of the order of 10 power 6 Kelvin. So 10 power 6 Kelvin also we have ionized gas. Okay, but since the temperature is high, the radiation which comes from this ionized gas is mostly X-rays. Okay, so we have cold gas, we have neutral gas, then we have ionized gas mainly in star forming regions. Then apart from that, we also have ionized gas which emits X-rays. Then, as you know, if you have that plasma gives what is called the synchrotron radiation. Okay. And we also have stars, as I told you, and we have dust in the galaxy. The studies of dust is also very important. The reason being, what the dust does is, it absorbs the light as well as the scatters the light. Okay, so due to the presence of light, we will be always receiving lesser radiation than what it is actually emitted. Okay. Therefore, to get the actual emission from the stars, we need to correct for these effects. So because of that, the study of dust also gets a major role in understanding these galaxies. So this dust is responsible for what is called the interstellar return, interstellar extinction. Basically, it is the accumulation of starlight which the dust does. Okay, then we have dark matter. Okay, and these are the typical dimensions of our galaxy. It has a core radius of 1 parsec. It has a mass of the order of 10 power 8 mass sun, and it has the luminosity of the order of 10 power 10 times the luminosity of the sun. So these are the basic constituents of the galaxy. That means our galaxy emits radiation coming from stars. Okay, it also emits radiation due to the hot ionized gas. It also emits radiation because of the relativistic plasma present in the galaxy. So the emission is a mixture of all these things. Okay, now this I already talked about. So here I show just a picture of the galaxy. This is the center of the galaxy. All these blue-like things are basically called the young stars. So have you heard about the classification of stars? O, B, A, F, G, etc. Okay, so these are hot type stars. They are OB type stars. And as I told you, bulge contains old population as well as the disk contains young population. Okay, now there is another picture. Okay, so here this I wanted just to read. As I told you, we have dust also, right, in the galaxy, and the dust also is concentrated towards the disk of the galaxy. And one of the important property of dust is that it absorbs the optical photons, and these optical photons are re-emitted as a low energy photon, and that low energy photon comes in the infrared region. So when you take an infrared image of the dark matter, right? So this you might have already listened, but as I told you, all these objects are moving in a Keplerian motion around the center of the galaxy. This formula is nothing but the formula which tells about the Keplerian motion of the objects. So if these objects have to follow a Keplerian motion, the x-axis is nothing but the galactocentric distance, the distance from the center of the galaxy determined in kiloparsec, and here is the rotational velocity. So assuming that all these objects follow a Keplerian motion, so we get a rotation curve like this. But what actually people observe is some curve like this. Okay, so if you take any particular distance, say 5 kiloparsec, r is fixed, g is a constant. So if you want to have a high velocity, the only culprit is mass. There has to be some more mass, right? So that is the way people concluded that our galaxy, apart from visible matter, also contains dark matter. So this is the evidence of dark matter coming from the study of the rotation curve of a galaxy. There is another evidence which comes from X-ray observations in clusters of galaxies. So that we will see. I will tell you about that evidence of dark matter when you go for clusters of galaxies. Okay. There are two evidences for the presence of dark matter. Okay. Okay. Now as I told you, we know about the stars, we know that they emit radiation, but actually to get a clear idea of the other properties of these objects, we need to know the distance. And measuring distance is one of an important parameter in astronomy, because without measuring distance, you may not be able to infer any of the properties of objects in a proper manner.